In the previous video, we took a look at being able to perform operations on complex numbers. In this section, we're going to take a look at how we can go through and solve quadratics that utilize the complex numbers within the solutions. Sometimes if we were to solve a quadratic, there's not any real solutions to it. Sometimes there's complex solutions. And the quadratic formula can help us to get to those quadratic sorts of solutions that are complex, right? Now remember, the quadratic formula says that if you have an equation ax squared plus bx plus c equals 0, then this is going to be the solution to it. And what happens is if we have a negative underneath the radical, that's going to turn into a complex number, or at least an imaginary number at some level. So we're going to take a look at two examples of how to go through and solve these types of quadratics when they do indeed have complex solutions. So we have x squared minus 2x is equal to negative 10. The first thing we have to do is we have to write it in the form ax squared plus bx plus c equals 0. So we're going to write this as x squared minus 2x plus 10 equals 0 by adding 10 to the left-hand side. We know that a is equal to 1, b is equal to negative 2, c is equal to 10. And we're just going to substitute those three values back into our quadratic formula. And so x is going to be equal to the opposite of negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 10. And we're going to divide all of that by 2 times a, which is 2 times 1. So again, just shove all of those variables back into our quadratic formula. Just like we've done before, we're going to simplify. Opposite of negative 2 is going to be positive 2. And underneath the radical, when we square the negative 2, that's just going to become a positive 4. So we get 2 plus or minus the square root of 4 minus 40 divided by 2. Another way to write that would be 2 plus or minus the square root of negative 36 divided by 2. And now this is where we start to see that there's no real solution to this, but there are two complex solutions to this. The way to simplify the square root of negative 36 is to think of this as the square root of 36 times negative 1, or that's the same thing as the square root of 36 times the square root of negative 1. We know the square root of 36 is 6, and we know the square root of negative 1 is I. So anytime you have a negative under a radical and lays a square root, it just turns into the square root times I. So we can rewrite this as 2 plus or minus 6i over 2. Then we can break this up into two different fractions. So 2 over 2 plus or minus 6i over 2. And we can finally get our answer of 1 plus or minus 3i by dividing both of those out by 2. Right, so that's going to be our complex solutions. And so that's one of the reasons why we have these complex sorts of solutions, or these imaginary numbers, is because when we have these quadratics, sometimes there's no real solution. A second example, just to make sure we have a couple of these, 2x squared plus 5x plus 8. Now this one we can automatically say is 2, b is 5, c is 8. And then we can go ahead and shove it into the quadratic formula. X is going to be equal to the opposite of b, which is negative 5, plus or minus the square root of b squared, 5 squared, minus 4 times 2 times 8. And then we're going to divide all of that by 2 times a, which is 2 times 2. Negative 5 plus or minus the square root of 25 minus 4 times 2 is 8. 8 times 8, 64 divided by 4. And now we can clearly see that we're going to get a negative value underneath of that radical. Okay, so we're going to rewrite this as minus 5 plus or minus the square root. We have our 25 minus 64, which should work out to be negative 39. And we're going to divide that by 4. Right. Now, 39 is one of those numbers that we can't simplify completely. But because we have the negative under there, we can write that as the square root of 39 times negative 1, which is the square root of negative 39 times negative times the square root of -1, or the square root of 39i, right? And so we're just going to substitute that back into our numerator. So we're going to say instead of square root of -39, we're just going to write that as square root of 39 times I over 4. And then finally, I think our directions say for us to write it in a form. Okay, so solve it. And we probably want to write it in the form a plus bi. So we're going to write this as -5 over 4 plus or minus the square root of 39 over 4 times I. And that's probably the best that we can get with this. Great. So hopefully this video helps you to understand how to solve these quadratics that have complex sorts of solutions.